Black holes are the largest energy collection stations in the universe. If you get too close, they'll swallow you whole and claim your energy as their own. Then, that energy vanishes forever. Or, it could be transformed into a cosmic fraud program, into an energy civilization capable of enduring until the universe's complete demise, or into the greatest explosion the cosmos has ever seen. But how? We know black holes absorb all approaching energy. Even light cannot escape. This is true. Yet for one reason, the strangest things you know about the universe become even stranger. Black holes can slip. When extremely massive stars die, their cores collapse under their own gravity into black holes. This means a massive object becomes incredibly small. So small it becomes the smallest object in the universe. But stars spin, and the fundamental laws of our universe tell us that spinning objects won't stop spinning on their own. We call this angular momentum. This angular momentum doesn't disappear. A spinning object spins faster as its volume shrinks. So, as it collapses, its angular momentum causes it to spin faster and faster until it collapses into a black hole. The black hole then maintains rotation at an infinitely high angular velocity. Some black holes spin millions of times per second. Unlike non-rotating black holes, rotating black holes possess an event horizon and a singularity at their mass core. This singularity is often described as an infinitely small point with zero area. But a point cannot rotate, so a rotating singularity cannot be a point. Indeed, it is a rotating ring. This ring has zero thickness, no area, spins at an extremely high speed, and contains all the mass of the black hole. The black hole spins so rapidly that it warps its own space and time. It literally drags space along with its momentum. This creates a peculiar region of space-time enveloping the black hole, the event horizon. If space and time completely collapse within the event horizon, they only partially collapse at the event horizon. Within the event horizon, nothing makes sense. It is a region you can enter but not leave, though it might not be a pleasant experience. Falling into a stationary black hole is like sliding into a hole. Falling into the event horizon of a spinning black hole is like spiraling into a deadly vortex. The black hole imparts rotational kinetic energy to everything that falls into its event horizon. Whether you like it or not, the vortex will spin you along. You'd need to be as fast as light to remain stationary within it, but that is impossible. However, there is a loophole. We can steal energy from it, and there is plenty to take. Take the black hole at the center of our galaxy, for example. We could steal the energy from stars evaporated into the galaxy over billions of years. The simplest, quirkiest way to get energy is to toss something into the black hole. We can observe the ring providing energy to objects entering its energy layer. It is like being swept round and round in a vortex of space-time. If you are clever, you can harness this current to swim faster. Practically, this means launching a rocket into the event horizon to make a trade with the black hole. We give it some mass, and it gives us rotational momentum. But it is not a fair trade. We get more. Typically, when you fire a rocket, you convert chemical energy into kinetic energy. It is like pushing yourself into a swimming pool. But if you fire the rocket within the event horizon, it is like being propelled into a wave pool. The rotational momentum of the waves gives you enough thrust to carry you forward. This thrust is so immense that you leave the energy layer with more energy than you entered with. The black hole gives you a tiny bit of angular momentum and slows its spin just a little. Obviously, it requires a lot of fuel. Fortunately, it isn't picky. In the near future, civilizations might harvest asteroids to feed into black holes when they need energy thrust. But there is a better way to extract energy from black holes. And it is quite bizarre. It would cause an unprecedented cataclysmic explosion. We only need two things to create a black hole: Big Bang, a spinning black hole, and a large mirror. This mirror would completely cover the black hole. It resembles a Dyson sphere, an ideal shape for harvesting an entire star's energy. Though the mirror is simple to construct, the black hole is far smaller than a star. If we build a mirror 10 centimeters thick, a solar mass black hole might require only the metal from a large meteorite. Once our mirror is ready, we need only activate one mirror surface and fire electromagnetic waves toward the black hole. You can imagine what happens next. Think of throwing a ball against a wall and having it rebound like a bullet. The waves strike the black hole at light speed. A small fraction falls behind the event horizon and vanishes forever. But the majority swirl within the energy layer. As the black hole imparts some of its angular momentum to them and amplifies them, they begin superradiant scattering, meaning they bounce between the mirror and the black hole, growing stronger. With each reflection, they amplify exponentially. By activating some mirrors, we can capture energy as they accelerate. Theoretically, this energy could become an infinite power source for all activities over billions of years. Or we could blow it up. If the waves aren't released, they grow increasingly powerful, drawing more energy from the black hole until the mirrors shatter. A supermassive black hole could release energy equivalent to a supernova, triggering an unprecedented cataclysm. This magnificent black hole explosion is known as the Penrose process and supersurface scattering. This isn't science fiction. In the distant cosmos, it may become the sole means of survival in a universe where we will perish. When all red dwarfs have cooled and all white dwarfs have become black holes, the cosmos will be eternally dark. Rotating black holes may become our only source of energy. If possible, the last vestiges of life might linger around black holes, a thought both terrifying and thrilling. It shows that even without light, we still have places to go.